I want to show you inside the HP01. The HP01, the most collectible of all HP calculators. I have one here which is working. And this is the original circuit. I don't touch it. But I have another one which is not working. It's just no response. And I will open it now and we'll try to repair it here. I have to sit down for having the microscope. The first is to open the back. And usually there is an original opener. I don't have it. It's very expensive to get all these accessoires. But this is a semi-professional watchmaker opener, and it should be possible to open the back without doing scratches. You don't see very much because it's so small, and if I try to show it here, perhaps we can see more. Every normal HP01 has a serial number. In this case, it's the 1801A. This, you know, all of you know, this is made 1978 in January. In A is USA, and the serial number for this month is 33,249. I don't know whether they built so many in this month. I don't think so, but in any case, it's made in January 78. And it's stainless steel, but this is it's only the back cover.
Sorry, question, the second number is not the week. Yeah.
It's the week. Okay.
It's a week.
Yes, right. It's from 1 to 54. There could be years which have 54 weeks, part of weeks. So, there are very precious collectibles which have no serial number. I don't have it here. So I open the back, and what you can see are the batteries. And I have to see it by myself. There are 3 batteries inside, and there is a cover which can be put aside. One of the batteries on the right is the battery which runs the circuit, and the 2 batteries on the left are running only the LED display. So you have the chance to press the LED display very often to show the time, and these batteries get empty very soon, and you can replace it without losing the time if you leave the right battery inside. That was the idea of the 3 batteries. Now I have to open more. First thing, I will remove the batteries. Oh no, first I will show you more. You see here a little button. Let's make it in the middle. This is a contact, this one, which gives contact to the inside of the back cover, because this is the beeper for alarm beeping, and the contact is all over. You can have the contact in a circle around, and this button will make the beeper beep. It has contact by a spring to the circuit below. Another part is this button. It's really a button. This is the reset button. They didn't have a reset circuit at that time, so whenever you have to replace the battery, you have to press the reset button. So only once a year. And this is a very dangerous button, because if you press the reset button and nothing happens for some reason, you tend to press harder, and this causes damage to the circuit, because below the reset circuit, we will see that later, is a contact which directly has a wire below. So you can press, if you press too hard, you destroy the contact to the inner layer. And then you don't have the possibility to reset again, and the watch is not working any longer. I never read about that, but yeah, I saw this hole which made somebody in this watch. You can see it later, just by pressing this reset button too hard. Normally you can press it like this. Okay, now let's open the first battery. My question, did anybody do that from you? Okay. This is my first time.
Shall we leave the camera?
So,
Shall we lift the camera a little bit? Camera.
lift?
Yes.
No, ich glaube nicht. We will go even more in detail later. So the size is okay. But I have to remove the battery. Now I got it. Now you see the contact and a sign negative down for polarity of the battery. And now let's open the other batteries. There is a half moon shaped contact spring which you can move. And now, did you see that? Because I see it only in the original. You can move it from right to left, and in 2 steps you can remove the battery. 1, then next. What you can see now is positive down, negative down, negative down. But let's go deeper. We want to go inside the HP01. The next barrier to go are the 2 slotted rings. There is an inner ring. You can see it here. Wait a moment. There is a slot of the inner ring, and there is an outer ring. This one. You see both slots. This here is the inner ring, and this is the outer. And now I have to remove the inner ring first, because this holds down the battery case. And my tool for it is the same as I have this, what is it called, scissors. What I have to do is to turn this ring, and normally you need a special tool for it, but I don't have it. Needle nose, pliers, but this is also possible to go, and this is not, I cannot show it in the microscope now. You have to look what I do here. I grab the slots of the inner ring and make the first turn, if I hopefully can get it. Okay, it turns. And now you have to repeat that several times, about 5 turns. And you have to be careful if you do it by yourself, not to turn the battery case. It tends to turn, and this could damage one of the springs below. So I need my concentration. Okay, it's moving. It's moving. very, very easy now. You will see the result in 1 minute. Please wait. So half a minute is over.
So you're rotating the inner ring or the outer ring?
I am rotating the inner ring, normally counterclockwise. So I need one more turn. Perhaps it's a little bit ambitious to show it in half an hour, because you should be careful not to damage anything. Can you please tell me if the minute is over? So, I got it. We can go on. You see, it's still the inner ring, but it's not longer connected. So I can remove this ring, and with the same, you see it here, with the same movement, also the battery case is free. The battery case is a really complicated part. If you lose it, I cannot repair your watch, because there are two springs which give contact from above to the circuit, and the battery contacts are also very essential. But now we can see more. We can see part of the circuit, and this is just the label, which I can remove. It's a vinyl label for not forgetting which polarity is used. Now you see this is an original HP01 circuit with quartz crystal and with the battery contacts, and you see the typical damage which can occur. You see the color, this green color, this is a leaked battery, and some of these traces are just wiped out. You see, this is not longer a trace, and you are not able to repair. And even more, this is the reset button. And you see the center of the reset button is broken. It's perhaps you can imagine, if you see it, it is pushed down inside the ceramic. And there is no chance, I see no chance to get contact again. So, let's do more. Now the outer ring has to be removed. The outer ring is now very simple. The same way, you have to turn it, but you have to turn it clockwise now, because this is a left-handed thread. So I turn it clockwise with my scissors, and it's moving. And this outer ring combines the keyboard with the case. Now some more turns and it's done. I've separated the golden case and just the circuit with the keyboard is left. Now how to remove the circuit? I have to remove this ring. And there's a special trick. They have slit this ring. It is a ring, I will show it in the microscope. This here, this part, you see the ring is split into two parts. And now you can lift one of these parts and then turn the ring. Oh, I need my hand. Still difficult. Okay. Now you can see the outer ring can be removed. It's done. And the next is we will remove the complete circuit. And that's very interesting, what you see now. On the other side of the circuit, you see the display and the contacts of the keyboard. And still this side with the quartz. And this is a trimmer for the quartz for getting more accuracy of the time. But this is still not inside the HPO. This is still the outside. For this purpose, I have another one. I have some tape for protecting it. I will remove this tape now. No, the tape is really fixed. So you need to wait another 10 seconds. Because these two parts of the ceramic module are glued together. And I cannot remove that easily, but I have done it already on this other part. What you see is another defective HPO1, which I tried to repair. You see there's a little wire here, but it didn't help. Now let's go inside. This is one of the rare views of the inside of a HPO1. You see six. Sorry? There are two parts. The other part is left is still connected by some tape here in the middle. I will fold it in the microscope. If I fold it, you see the keyboard contacts, and I fold it back, and you see the circuits. And these circuits are 6 of them. First, which I will show you, there are 2 circuits which are identical. This one and this one. And these are the 2 ROMs, which made me very angry to read them. Then this one is the display driver chip. Then I don't know exactly which one. This should be the control and timing circuit. Below, this is a resistor and a capacitor, which are related to the oscillator. So this is the oscillator chip, and this is the arithmetic chip here. And what you can see, there are very, very tiny bond wires which connect the dies with the circuit. And when I tried to read the ROM, the difficulty for me was how can I get with the probe to that very small pieces. Finally, first thing I made, switching on my oscilloscope and have very carefully oscilloscope probes for reading signals, looking what is signal. There's no documentation which line has which signal. And I found first an oscillator signal of the quartz is 38,400 hertz. Then I found an 800 hertz signal. This was divided by 48. And I found some signals which reminded me to the HP25 signals, which I already knew. So there's a bit serial address and data communication between these chips and between the ROMs and the chips. But after only 10 minutes of measuring, you see I'm not so young anymore, and my hand is not so quiet, so calm. So I ripped off one of these bond wires by just moving the probe. And you can see this circuit is damaged by it. The missing wire, clearly seen, is this one here. There is a missing connection. And I will show you this in some bigger version. Wait a moment, please. I brought some pictures which I made with a real microscope. And these pictures could be found here. I'm sure this one. This is a better view of the ROM chips. And this is the ripped off wire. So you see, there's no chance ever to get back a wire to that. And if this would have been the data line to a ROM, then there would not have been an HP01 repair kit. But fortunately, you can ask me, how did I find out? It's the carry bit of the arithmetic processor. The carry bit is just a wire from arithmetic to register circuit, and it is used in arithmetic by addition and subtraction, as you know.
So did you notice the clock going to 24 hours and then 24:01?
Yes. The carry bit, just 1 minute, because it's so interesting. I tried to restart the circuit by applying power and have my oscilloscope on the lines. And normally there is the inhibit line, which makes the chips to sleep. After 3 seconds after you press a button, you have to go to sleep. And this line normally went too low after switching on the power. After 5 seconds, it went to sleep. And with the ripped off carry bit, it did not go to sleep. So I found later the place in the microcode where it hanged. So there was an endless loop because the carry bit was not set. So let's go on. Is this inside the HP01? No, it's not inside.
You want to show us the electrons and the protons?
Yes. We go even further. Now, it's very nice to see the details of the chips with this microscopic image. You can see they had a lot of integration in this. This is only, it could be 20-fold. I'm not sure. I have 10, 20, 10 or 20, because 40, my microscope has also 40, but this is not 40, this is 20, I think. Yeah. I have another picture. This one. This is the ROM. And you know, somebody tried to read ROMs optically and succeeded with the HP35. You could see every bit, but I didn't see any bit. This was my first approach to read the ROMs. I thought perhaps I have a good microscope, I could see, but there was just this flat area all over. Perhaps some more very interesting to see. And this is dirt, some fiber laying on the tip. I don't know. It's from me. It could be in production also since 40 years there. I'm not sure. So what do I mean with inside? Inside means what is inside the ROM. What does the machine work? What is necessary to understand how it works and how to build a replacement for it. And that is just software. And the best wonderful document for having an insight to the HP01 is a patent from 1977 or 78. And this is the US 4150 patent, which contains 150 pages, which I will show you now. No, this was a joke. The 150 pages are very important for understanding the HP01. It's interesting to use. I just want to show you the amount of information. The patent starts with a general description of the watch, the display, what it could display, and then, hold your breath, follows 95 pages of schematics. This is a major part of these 150 pages. It's just schematics. This is something for you, yeah, especially. You want to rebuild it? Read the schematics. You can put it in one little FPGA today. There are the registers, there are the AND gathers, OR gathers, flip-flops, everything there. And I have to go on. A little bit faster. I cannot explain you every cell. Even if I try, I don't have an idea what they do in detail. But on a higher level, in the level of registers, you can understand what they do, of course.
But the patent was 2 years after the watch came out. This is quite strange.
No, that's just the patent was filed before. And the first page is written 1975, but it was approved in 1978. So, I don't go into detail, but now there is text. And this text describes the registers, describes the functions, describes very detailed what the watch is really doing. And I got lots of information from this text, how the control and timing is working, and some flags. Here is the instruction set. It's very similar, as you know, to the HP25, but the registers are smaller. They have only 48 bits, not 56. And then, after having read all this, I tried to figure out how to make an emulation. This is the next part of this document. is a complete listing of the ROM contents. And now we have arrived at the inside of the HP01. This is what is really going on. And my first step before I read the original code from the ROM was to type these instructions into my computer and make them run. And indeed, it's a complete HP01, but missing some functions of the later model which came to the market. The addresses are still missing. You have to calculate the addresses, and then it's a running code. It's together a little bit more than 2K. The original was more compressed and was fine placed in 2K of ROM. And this is inside the HP01. So, do we have some minutes more? What I'm doing now, I want to repair this watch. And I built a replacement, which is a modern type of the HP01. To close this, where's my mouse? Go back to the microscope, please. Is this? Yes. Okay. What you can see is my version of the HP01. I used the PIC 16LF1590 processor, which is low power version. It has sleep mode up to 20 nanoamps and a real-time clock circuit, which is no name. Now, it's the PCF2127. The only reason for removing the writing is it was too high. It was much too high. I had to for every replacement I have to remove 1 millimeters of plastic on the bottom side and the top side. And I had not much choice for choosing another chip. It's really not easy to find some working constellation. And they communicate together, and you can attach the original LED display, and then, if the software is running, you have a repaired HP01. I entered this circuit to the watch. You see, I have a already soldered LED display, and it's already folded. And now there's a little speciality. You have to add plastic strip on the left side to avoid contact problems. I cannot do everything under the microscope for some reason. And it fits. It's HP01. Yes, let's do it fast. I have only 5 minutes left. I will apply the outer ring first. I have the labels, they are exactly fitting.
Do you still use the same power setup? The batteries for the display and for the clock?
No, it's different. For power supply, I use only 2 batteries, which have together 3 volt, and the whole circuit, including LED, is driven by 3 volts by 2 batteries. So the third place is not used. It's empty. But if you really are a purist or an enthusiast, you can enter a gold cap during changing of batteries into the third position, and you don't have to set the time again after battery change. even with the new one. So now I enter the
DCF receiver.
sorry,
You haven't integrated a DCF receiver.
too big, too big. I'm sorry. So no, that was too early. I fix the outer ring by turning counterclockwise for closing, because it's the special negative thread. You can see I just turn it around.
And your hardware replacement runs the original firmware.
Yes. That was the reason for reading the ROMs.
So you did manage to read the ROMs after all. You did not rely on the patent.
I have the patent running on the HP25, the patent code. So I saw it's working, and it's not many things are missing. The percent function is completely missing, and some details. The stopwatch of the original is counting downwards. It's a countdown. You can program it as a countdown counter, and when it reaches 0, it counts upwards again, and the prototype just stops. So some differences. Now I take the inner ring. I cannot show that. I'm sorry.
It's okay. You get a picture.
You see, it's very easy.
That's for everybody.
So the kit isn't really a kit.
Do it yourself.
I offer it as a kit only for the very experienced engineers. Now this is really the most difficult part, to get the inner ring in place. But I got it.
So apart from the ROM, apart from the microcode, the rest of the architecture is like the 25.
It's similar, but the instruction code is different. It has special instructions for a clock, like start, stopwatch, stopwatch. These are special instructions, or show clock to display. These registers have dedicated instructions, and also the code is meant for only 48-bit registers, so the fields are different, the field sizes, and the arithmetic are some different. Sometimes you have code C is exchanged with B, and now you have C is exchanged with A, or you have to take into account some minor differences. So I got it. Looks fine. One more turn. And now I have to be lucky, because I made it very fast now. I hope the contacts of the springs found their right place, and I will insert the battery now. This is how it looks with the new circuit. Looks like the same with the label. I have the same polarity like in the labels. So positive down on the left. And negative down to the right. And nothing happened. Oh, this was wrong. Negative down is I made it wrong. Positive down. Negative down. Next try. Yay! It's running. Thank you. Thank you very much. Now you can set the time and date.
You can keep that in memory?
Or we can start with the best.
It starts with the 1st January of 1900. This is the stylus. And let's have a small calculation. Which number should I multiply or add? You can say, I take 5 plus 5. This is 5 plus, 5 plus 6 ist gleich 11. And you see it's an algebraic calculation. Thank you very much. F1 shows H01. And it has more functions. F.
This is not in the original.
No.
Okay.
I integrated a counter. This is the counter. I started just now with 0. It counts how long the display was on in minutes. So you can really see how long the battery lifetime is. It's normally you have about 10 hours of showing the display. And if you don't show the display, it's calculated of 7 to 9 years with these 2 cells. This is modern circuit. So I didn't make it for for cheating. It's just you can see that it is not the original if you want. And even more, I have a ticker text. It's my name.